Number 3. For each of the functions below, state the location of the function's absolute max and minimum on the interval of A. If not information, say so. Assume that any critical numbers mentioned in the problem statement represent all the critical numbers of the function on the interval from A to B. Okay, so this says, reading using our calculus knowledge, the slope is always less than or equal to 0 for this function. It's always going down for all x on A to B. So it could equal 0, or it could be negative, or equal to 0 and negative. And so, do we know where the max is? Yep, we know that's the beginning of the interval at A, and we know the min's at B. Has to be at those places. Okay? Now, if it flattened out and it was completely flat for ways, we might have more places, but that would make it kind of a weird function to go flat for ways. Turns into a constant. But anyway, could be. But at least we think it's going to be min at B and max at A. B. G has a critical number, C, which is between A and B. The slope is positive when you're less than C. So we're looking at the interval from A to B, and C's in here. And before C, the slope is positive. And after C, the slope is negative for after C. So if it's negative after, it has to be going down, and before it's going up. And so the max has to be at C, and the min is at A or B, but we can't tell which one's lower. So all we know is the max is at C. H of A equals H of B. So the beginning of the interval and at the end of the interval, it's at the same height. And it's concaved down for every place in between. The only way to get from there to there and be concave down is something like this. Now, it might be steeper at the beginning and less concave down at the end, or it might be this way. But wherever the max is somewhere in the middle here, we don't know where, but we know the min is whatever H of A is, or H of B. They're both the same. So that's the minimum value happening at A and also at B. And some place in between is the max. And this last one here, the function is a positive function at A. So at A, the graph is above 0, and at B, it's below 0. So it ends up negative at B and positive at A. And there's a C critical number between A and B, and the slope is negative before C. Before C, the slope is negative. So C somewhere in here, and the slope is negative before C, and the slope is greater than 0 after C. So it's going to have to go down pretty far if it's positive afterwards and get to a negative value. And so the slope is negative till C, and then it's positive slope after. So to have a positive slope getting to a place that's negative at B, this has to be the min at C, and this has to be the max. Max is at A, and min is at C. All right, and the final problem. 4. So S of t equals 3 sine, and I'm going to distribute the 2t minus pi over 3 plus 5. And we're supposed to find the exact absolute value on these intervals and the minimums. So we're going to find the derivative. S prime of t, that's a constant times this, so it's going to be 3, derivative sign is cosine of 2t minus pi over 3 times the derivative of the inside, which is 2, plus the derivative of 5, which is 0. So this is 6 cosine of 2t minus pi over 3. If we're trying to make this equal to 0, the cosine is 0 at pi over 2 plus multiples of pi, as we discussed in the previous problem. Pi over 2 plus pi plus pi plus pi, or pi over 2 minus pi minus pi minus pi. Those are all the places that will make the cosine of that angle 0. So to find t, we have to say 2t minus pi over 3 has to equal one of these special places. To do that, to solve for t, we're going to add pi over 3 to both sides. So we're going to get 2t equals, this is 2 6 plus 3 6 is 5 pi over 6 plus m pi, getting the common denominator. So this is 2 times 2, and this is times 3 and times 3 to make the common denominator. Then I'm going to divide everything by 2, and so t has to be 5 pi over 6 divided by 2 is 5 pi divided by 12, half as much, plus multiples of pi over 2. If this is in 12ths, I make this into 12ths by multiplying by 6 and by 6. So, the places that the derivative is equal 0, the critical values are 5 pi over 12 plus 6 more of those would be 11 pi over 12 plus 6 more is 17 pi over 12, etc. And going the other way, subtracting 6, I'd have minus pi over 12 and minus 7 pi over 12. That's all the critical values for this function. So, part A says, look at this interval from pi over 6 to 7 pi over 6. So A, pi over 6 is the same as 2 pi over 12, and 7 pi over 6 is 14 pi over 12. So 2/12 is bigger than this, that's negative, so this one's between 2/12 and 14/12, and that one's between 2/12 and 14/12. So for A, I have to plug this in, that in, that in, and that in to look for my max and mins. And I'll let you type those into the calculator. That should be easy enough to do. For B, same equation, so same critical values. I got to find the ones between 0 and pi over 2. 0 is going to be here, and this is going to be 6/12 here. So now I got to plug in 0, pi over 2, and 5 pi over 12 and decide which one's the largest and which one's the smallest. For this one, C, I have to plug in 0 and pi over 2. This one's between 0 and pi over 2. That one's between 0 and pi over 2. And that one's between 0 and pi over 2. And if I add, what was I adding? 6's? That'd be 23 3 pi over 12, which is still less than 2 pi. So I would have to type in, find the value of this sign for all of those and for 0 and 2 pi. Let's work that one out. I'll show you how I would plug these into my calculator. Just to make it easy on myself, I'll go to y equals and type in 3 sine parenthesis 2, no, I already have a parenthesis, 2x minus pi divided by 3, close parenthesis, plus 5. And then I would go to my table set and make sure it's on ask, and then go to my table, and then I'm having to put these in several times. These are all positive intervals, so I can put if I remember which ones I do, 5 pi divided by 12, 11 pi divided by 12. So the height at this one is 8, this one it's 2, 17 pi divided by 12, and this one's 8 again, and probably this one's 2 again, 23 pi divided by 12, and it's 2 again. And then for C, then I have to start plugging in some of these ends of intervals. So the critical ones are giving me 8s and 2s. If I plug in pi divided by 6, I get 5. That's neither a max nor min. That's somewhere between 8 and 2. In fact, we said for A, these are the two endpoints, and the only ones that were between them were these two, and so 8's the max, min is 2. Now on C, if we plug in 0, we get 2.4. Well, it's not going to be a min, and it's not going to be the max. And 2 pi, we get 2.4. It's not the min nor the max. The max is 8, the min's 2, and all those are between 0 and 2 pi. So the only way that 8 or 2 would not be the max and min is if the interval doesn't include some of these. And so you got to figure out which ones are in between and which ones are not. Okay?